Please write down our new topic. Alibek, write down the date. Write down the new topic. Definition of defined integral. And the fundamental theorem about our calculus. Newton-Leibniz formulas using. The aim of the lesson, please read. What should you learn?
Know the concept of definite integrals and be able to calculate defined integrals.
Before the last lesson, we studied the undefined integral, yes? Let's revise our lesson about the formulas of indefinite integral. Match the formulas. Please, matching the formulas about undefined integrals. Okay? Undefined integral. How many formulas do you know? Match. Have you finished? Yes? Okay, swap. Check your partner. Swap. Sabina and Bojan, Aybar and Talibet, Altınay Alia. Swap, please. And check your partner. The answers on our presentation, please. Have a look. Have a look. Check your partner answers. Finished? Okay. How many mistakes?
0.
0. All of them? Wow. Ruslo, how many mistakes? 0. Good job. How many mistakes, Tamiris? 0. Okay, good job. Well done. How many mistakes? 0. Any questions about the formulas of indefinite integrals? Any questions? No. Okay. And what is the main formulas of indefinite integral? What's the main formulas?
Every formula.
Every formula, but it's a what is the main formulas? How do you call it?
The formulas of
Degree or power? Power root formula is the main formulas of integrals, yes? Okay. about defined integral.
Yeah, the reason why I'm using C and D instead of A and B is so I can use A and B for later. And let's say we set up some function capital F of X, which is defined as the area under the curve between C and some value X, where X is in this interval where F is continuous, under the curve. So it's the area under the curve between C and X. So if this is X right over here, under the curve F of T dt. So this right over here, F of X, is that area. That right over there is what F of X is. Now the fundamental theorem of calculus tells us that if F is continuous over this interval, then F of X is differentiable at every X in the interval, and the derivative of capital F of X. Now let me be clear. Capital F of X is differentiable at every possible X between C and D, and the derivative of capital F of X is going to be equal to lowercase f of X. Fair enough. Now what I want to do in this video is connect the first fundamental theorem of calculus to the second part, or the second fundamental theorem of calculus, which we tend to use to actually evaluate definite integrals. So let's think about what f of b minus f of a is, what this is, where both b and a are also in this interval. So f of b, and we're going to assume that b is larger than a. So let's say that b is this right over here. We do that the same color. So let's say that b is right over here. F of b is going to be equal to, you just literally replace the b where you see the x, it's going to be equal to the definite integral between c and b of f of t dt, which is just another way of saying, that the area under the curve between c and b. So this f of b, capital F of b, is all of this business right over here. And from that, we are going to want to subtract capital F of a, which is just the integral between c and lowercase a of lowercase f of t dt. So let's say that this is a right over here. Capital F of a is just literally the area between c and a under the curve lowercase f of t. So it's this right over here. It's all of this business, all of this right over here. So what is, if you have this blue area, which is all of this, and you subtract out this red, this magenta area, what are you left with? Well, you're left with this green area. You're left with this green area right over here. And how would we represent that? How would we denote that? Well, we could denote that as the definite integral between a and b of f of t dt. And there you have it. This right over here is the second fundamental theorem of calculus. It tells us that this, if f is continuous on the interval, that this is going to be equal to the antiderivative, or an antiderivative of f. And we see right over here that capital F is the antiderivative of f. So we can view this as capital F antiderivative.
Any questions from the video?
No.
Okay, let's consider the questions from the video. What is the integral? What is the defined integral? Defined integral, it's an interval with limits a and b. And what is the area? And finding the area from the shaded region. Okay? It's a defined integral. A and b, it's the limits of the integral. Here we have the defined, here indefined integral. Let's consider the example. It's a Newton-Leibniz formula, or the fundamental theorem of calculus with limits a and b. We have the example of 2x function with limits 1 and 2. 2 is upper limit, b is 1 is lower limit. First of all, we should integrate What is the integral of 2x? X squared. It's the opposite of derivatives. Yes, you know. Then you should substitute the limits 2 and 1 instead of x. Then calculate. The answer is 3. Or the second case, finding the defined integral, you should draw the linear function and denoted limits 1 and 2, and that shaded the region between 1 and 2, and find the area. And using what? The formulas of area here. Area is 3. How to find the area? With the trapezoid formulas. The second place, area of trapezoid. Okay, open the book, please. Let's consider with the group, please. Work with the groups. Page number 58. First of all, read about the defined integral, about the formulas. Then consider the example. Your example is 9. 9. Here, consider and discuss. Okay, with the group. Your example is what? 5. Discuss and consider together. Work with the group. Your example is number 30. Please discuss and consider with the group. Write down. Ask questions from other and second.
We have the fundamental theorem of calculus. It's terminals B limit, A limit, f(x) and b(x) there equals
Louder, speak louder. Discuss. Write down. Discuss. Discuss in English. Write down. Sabrina.
First function is x cubed is equal to no wait first
Then there is minus in the brackets minus cosine 0.
Lower bound is 3. Multiply 0. Plus 1.
so at first we need to
Formulas of trapezoid girls. Ali Altay.
You see here.
Two bases multiply the h. Divided. Represent. That's all. Have you finished? Are you ready? First, second, third group.
Yes.
Are you ready? Second group ready. Third group. Finished? Girls, finished?
Our group is ready. Our tree is well done.
Okay. Who wants to go to the bathroom? Tamiris, go. Please, girls, others, write down the example, Tamiris example, and listen.
My example is fifth example.
Open your copy book, listen.
60th page. There is even.
Listen, please, and write in your copy book. Sabina, Bogdan,
So we know the fundamental theorem of calculus. It's B, the other is A, f of x equals to B minus A. So here we're doing by this formula. At first we should take sine x out of integral, do kind of opposite integration. So it will be minus cosinus x. So the limits are p and 0. Then we use this, so we can hear that b here is p, and we write it as cosinus p and minus, in the brackets, minus cosinus 0 as a limit of this function. So in a result we got cosinus p it equals to 1, and this minus r gives us plus. Cosinus 0 will be 1, 2. So answer is 2.
Any questions? Okay, write down your copy book. It's the first example. Second, ready?
Yeah.
Please show me your work.
Okay. The
Girls,
first
others,
our
please write down the example and
is-
ask the questions.
Our example is
Okay.
integral, defined integral with the limits of 3 and 1, then 2x squared plus 3x minus 4 and dx. First of all, we divided it by the members, and also we take the constantas out of the limits. We have like 2 and the limit 3 and 1 with the x squared dx plus 3 with the limit 3 and 1, and then x dx, and we have 4 with the limit of 3 and 1 and dx. Just then we need to find the antiderivatives of all the limits, and we have like 2. There is x squared divided x cubed divided by 3. Then with the limit of 3 and 1, then plus 3 with the there is x squared divided by 2 with the limit of 3 and 1 also, and then minus 4. There is gonna be x with the limit of 3 and 1. Okay. Then we find we find everything with the, like, we put the 3 in the x, we put 3, we have like 27 divided by 3, then and we subtract 1 minus 1 divided by the 3, then we plus the 3, then we have like 9 divided by 2, and subtract 1 divided by 2. Then we have the 4 x cubed is gonna be 3 minus 1. Yeah. Then we have the answers. We like calculate them, and we have like 52 divided by 3 plus 12 and minus 8 when we calculate this. And the final answer is gonna be 64 divided by 3.
Good job. Any questions? Please. All of them clear?
Good job.
And third group? Write down the third group's example is harder because we should use the substitution method.
Our example is number 13 on page 64. It's right. First, we go 3x plus 1 dx. We have two ways to solve this. First one is by substitution. We can make term and define it as u, and it will be 3x plus 1, and find the derivative of the u, 3x plus 1 dx. We can solve it and have answer the u x. Wait, sorry.
3.
3 d. So we have this. We have boundaries. It's 0 and 1, and we can find the bounds. First bound it will be wait. We can find the u and put the boundaries in the term of u. So first bound is u in term of 0. It will be 3 multiplied by 0 plus 1, and we have answer 1. Second boundary is u in the term of 1. It will be 3 multiplied by 1 plus 1, and it's 4. So we have this integral, and because the 3 is a constant, we can put it out of the integral. It will be 1 divided by 3 integral. This we can put there we can put these boundaries, and it will be 4 and 1 square root of u and the u. So we can we can write the square root as a degree. It will be 3, 4, 1 u 1, 2 the u, and we can see that it can be easily solved. 3 multiply u with degree plus 1 divided by the degree plus 1, and it will be 1, 3 multiplied by u 3 plus 2 and 3 divided by 2. The boundaries 4 and 1. It's 1, 3. We can just write 2u because the 2 will be go to the upstairs. And there it's 9 and degree. So we put the boundaries that we have. It's 2 multiplied 4 in the degree 3 divided by 2, and there is 9, and it's substitute from 2 multiplied 1 in degree 3 and 2 divided by 9. We have answers 16 divided 9, substitute from 2 divided by 9. And the answer is 14 divided by 9. It's the first method to solve it, and we have the second method. Second method is quite easier. It's 1, 0, square root of 3x plus 1 dx.
Write down in the copybook.
So we can just write it as the first one, 0, 3x plus 1 to the x. And as we see, it can be solved as the first method, 3 multiplied by 3x plus 1 degrees 2 plus 1 divided by plus 1 in boundaries 1 and 0. It's 1, 2, 3x plus 1, 3 and 2, it's 9, 1 and 0. And there is the substitution method. Or, sorry, we just substitute the boundaries. 2, 3 multiplied by 1 plus 1, 3, 2, 9, minus 2 multiplied 0 plus 1, 3 and 2, 9. And by solving it, we have the same answer. It's 14 divided by 9. So,
Good job.
Let's practice our topic. Go to the Blackboard and page number 65. Check yourself number 2. Please, let's start. If the limits are same, the answer is 0 here. If the limits are same, то логично будет limits are same, the answer is 0. The limits are same, answer is 0. Check yourself number 2 and same. Same, and answer is 0. Write down, write down. Altnaya, ja?
Like for the degree of no, why? I don't know. It's me.
Let's conclude our lesson. Take your phone and go to the Kahoot.it. And down your pin. All of them here?
No.
No? I'm here. Okay, let's start. Take your pen, copybook, and so. Let's start. Discuss with your friend. Evaluate the following. Baljan first. Start. Evaluate the following. Again, define the integral. Complete.
Complete.
Skip. Finished. No. 7 right answers. Okay. Baljan, again first. Next one. Easy, yes?
Yes.
Very easy. Answer is
Right.
a squared minus e. Again, Baljan first, Alia second. Third one, Yevgenas. With square roots. Family
Yes.
And first place,
No, it's not good.
let's reflect our lesson. First group. Pluses, minuses about lesson, your ideas. Second group also. Third group also.
We're playing reverse.
Yes. First group. Let's listen. First group.
The first class we learned today was about the fundamental theorem that was useful, and we learned how to use this theorem for our integrals. And minus was the some kind of problem solving was hard, but we exposed that, and we also encourage for everyone to do this.
Second group.
So I want to say that we learned today is fundamental theorem of calculation, and I want to say that the first so it is very difficult, but now I work with my group, and I want to say it is easier than I thought, and a lot of the rulers is really helping today, and the most striking feature is my group, because I worked with them, and it is the most important part of today.
Thank you. I also thank you. The third group, last one. Sabina.
Today's lesson was very interesting, and we, with my group, worked together hardly and play Kahoot games. It was very interesting. Thank you, teacher, for today's lesson.
Thank you also for you. Thank you for the lesson. Please and goodbye. Homework in your chat. Okay?